So in this video, we'll be doing part 2 of 3. And in this lesson, we'll be doing calculus of motion. We'll be dealing with distance, velocity, and acceleration. And this is another video where I'll just give you everything you need to know when you're answering calculus of motion in an exam. So in an exam, they'll give you one of 3 problems, either maxima and minima, which I covered in the previous video, calculus of motion, which I'm going to do here. And the next or the last video of the 3 series will be rate of change. So they always ask one of the 3 topics in applications of calculus. So what you really need to understand in calculus of motion will be using distance, velocity, and acceleration. So in this quick table extracted from the Crack the Maths Course study guide that I authored, it just gives you a quick schematic of what you need to know or what's to come. So what you need to know is that velocity, instantaneous velocity, is the first derivative of the distance in terms of t. So distance, to calculate velocity when you're given distance, you just derive once, and velocity, instantaneous velocity, is just given as velocity in terms of time. But when you're given distance then, and you're asked to calculate acceleration, so you have to derive the distance 2 times. When you want to calculate the instantaneous acceleration and you're given the formula of velocity, you have to derive velocity once, and instant acceleration is just given as acceleration in terms of time. So now let's apply this in real time to really show you how to really apply this, and I'll be repeating it, really going through the lesson. So let's just revise what we just covered in the previous point. It's that you have the 3 variables, really, or 3 matrices that you have to really pay attention to. It's distance in terms of time, velocity in terms of time, and acceleration in terms of time. So what's really important here for me that I discovered that helped me answer all these questions really and get them correctly is that whenever they give you distance and velocity and acceleration, how these 3 relate is that if they give you a formula in terms of distance and they ask you to calculate the velocity, right, or speed, what you need to know is that to calculate velocity or speed using the distance, you just need to derive your distance in terms of time once. It'll be equal to velocity. And if you have to calculate acceleration when you're still given the distance, you have to really derive your distance in terms of time twice. Then it'll give you acceleration. And to continue on the same theme, what if they give you then velocity? If they give you velocity and you have to calculate acceleration, you just need to derive your velocity in terms of time once, and that will be equals to your acceleration. So for me, this is a game changer in this section. So memorize this, memorize it, understand it. So I'll really be applying the same principles I'm teaching you to answer this question, and you can answer any question on calculus of motion with these principles. So let's go ahead and attempt this exam type question and see what we get. So we're given that a car speeds along a 1 kilometer track at 35 seconds. So it covers that 1 kilometer track in 35 seconds. Its distance in meters from the start after t seconds is given by st, s in terms of time, s being, remember, they just told us what that is. They're telling us that it's distance. So the s is not speed or anything, it's the distance in terms of time. T squared is equal to 25t. So this will be our main formula we will be using, which is distance s in terms of time is equals to t squared plus 25t. The first question, they say write down the expression for speed velocity of the car after t seconds. So they just want the expression, nothing more. So the expression, we're given distance here. This formula represents distance. Then how do we write it in terms of speed or velocity? Remember, when you're given the distance, how to represent it as velocity, we just need to derive it once. So we're going to go ahead and derive this formula once. It will be s prime in terms of t, will be drop the exponent, it will be 2t minus 1, and then it will be really 25. So this expression is equivalent to it being velocity in terms of time is equals to 2t plus 25. And then we would have answered our first question. That easy. And then the second question is asking us what? Determine the speed of the car when it crosses the finishing line, or the finish line. So after how long does it cross the finish line? It's after 35 seconds. So what do we have? We have the velocity of the car, and it crosses the finishing line after 35 seconds. So they're asking us to determine the speed that it will cross the finishing line after 35 seconds. So remember, it's in terms of time, so we just substitute our time with this t plus 25, and our velocity after 35 seconds, or when the car crosses the finishing line. If you plug this into the calculator, 2 times 35 will give you 70, 70 plus 25 to give you 95, and velocity is meters per second, so it will cross the finishing line at the velocity of 95 meters per second. And let's move on to the next question, which is also very interesting. It says, hence or otherwise calculate the acceleration. No, it says write down the expression of the acceleration of the car after t seconds. We just want the expression of the acceleration, and we're given the formula of distance. And we always reference our initial formula of distance, which is s of t is equals to t squared plus 25t. So to represent acceleration using distance, it means you have to derive the distance formula or the distance equation twice. So it will be the first derivative in terms of t will be 2t plus 25, which is our velocity, but we derive it again to calculate our acceleration, which will be in essence 2. So this will represent acceleration in terms of time will be equals to, formula will be equals to 2. And this will be our acceleration formula in terms of t. Then we move on to the fourth question. Fourth question is asking us hence or otherwise. Whenever they say hence or otherwise, it just simply means use the previous answer to answer the following question. Calculate the acceleration of the car after 5 seconds. So to calculate the acceleration of the car after 5 seconds, this is our formula. So a of 5 is still 2 meters per second squared, meaning that if there was a t here, we're going to substitute t for 5, but there is no t. It's just a constant acceleration of 2, meaning that this car will accelerate from start to finish at the same acceleration of 2 meters per second. And moving on to the last question, which is really fun as well. We are asked in this instance to calculate the speed of the car when it is 25 meters down the track. So 25 meters down the track, what does that mean? We have to calculate it 250 meters down the track. So they're asking us to calculate it at a specific point. So they're asking for speed. Remember the formula for speed? The formula for speed or velocity, it discovers that it's 2t plus 25. So they want it at 250 meters down the track, but this formula has no distance. So we have to calculate what time to substitute so that we know at what time will it be passing 250 meters. But we have a formula representing distance, which is t squared plus 25t. So they're giving us the distance, which is 250. So we just substitute 250 t squared plus 25t, and then we just have to solve for what t is. T squared plus 25t is equals to 250. So we can just rewrite this as our quadratic, and see that we'll probably need to use quadratic because there are no factors. Yeah. So I'm just listing all the values that we're going to be using. In our quadratic, in terms of t, it will be negative b, or b is 25, plus minus square root of b squared 25 squared minus 4ac. A is 1 and C is 250. Negative 250. All divided by 2a, which is 1. So if you plug this into your calculator, you'll find that you get a t value. Two t values, one will be positive, one will be negative, but we're only interested in the positive one. The positive value will be 7,66 seconds if you plug this into the calculator. So if you want me to rewrite this so it's more visually appealing, t will be equals to minus b, 25, plus minus the square root of b squared, 25 squared, minus 4a, which is 1, and c minus 250, all divided by 2 times 1. And you'll get t to be 7,66. And this is the positive time, because time is always positive. So since we have the time that it will be passing 250 meters at 7,66 seconds, we can substitute our time into our velocity formula. Then v of 7,66 will be equals to 2 times 7,66 plus 25, and it will pass 250 meters, traveling at a speed of, if you punch this into a calculator, you get 40,82, because it's going to be 7, and 2 times 7,66 plus 25, which is 32, not 82. I had to double check that because it didn't look right. So meters second. So that will be the speed that it will be passing 250 meters down the track. And in that way, you can see that we really simplified calculus of motion. And I think the most important is to remember, the main takeaway is to always apply the principles of distance, velocity, and acceleration on every single question you get on calculus of motion. So if you found value in this video, please hit the like button, and you can also share it with a friend so that you really help one another. And be sure to look at the last video I do on rate of change, and I'll catch you on the next one.